morning all of you. Now this is the next point as per Fajns rule. Applications of the Fajns rule. It is also called as significance of the Fajns rule. Now when we have taken Fajns rule, now what happens in case of the Fajns rule? Generally there are some ionic compounds. These ionic compounds can be formed with the different ions. But what happens here, some colorless ion can be combined with each other and formation of colored compound can takes place. Also some ionic compounds can be possesses low melting point, low boiling point, and this can be explained by the scientist Fajn why this can be happens, and this can be happens due to polarization effect. When we have taken cations and anions brought together, anion polarization can be takes place, we have seen in the last points, and due to anion polarization there is a development of covalent characters, covalent bond occurs instead of ionic bonds, and hence what happens, due to formation of the covalent bond instead of ionic bonds, here these compounds can be shows low melting point, low boiling points. This idea can be explained generally the scientist Fajn. Now what are the applications of the Fajn's rule? Fajn's rule can be used the information about the some compounds. Suppose we have taken silver chloride. AgF is soluble in the water. If we have taken AgF, it is soluble in the water, but AgCl, AgBr, AgI are insoluble. Why this can be happens? And this can be happens that suppose we have taken AgF. Now this AgF, it is a ionic compound. Strongly it is ionic. But what happens when we comes in case of AgCl, AgBr, AgI? There is an increase of covalent characters can takes place, and due to formation of the covalent bond instead of the ionic compounds, here only this can be soluble in the water, aqueous solvent, which is aqueous solvent, and these are insoluble in case of generally waters in the aqueous solvent. Due to formation of here high covalent bond will becomes, covalent characters will becomes, hence all these are insoluble. Now this will be one idea as concerned to covalent bonds. Second will be KCl is insoluble in alcohols, but Ki is soluble. We know that here this alcohol is a non-aqueous solvent. Now this is a non-aqueous solvent, and hence what happens, this Ki which possesses more covalent characters, more covalent bonds, and therefore this Ki is soluble in case of the alcohol, where this should be high percentage ionic characters are present, hence it is insoluble in case of the alcohols. This idea can be explained. Now also what happens here, suppose we have taken alkali metal chlorides. Some alkali metal chlorides, they are insoluble. Why insoluble in case of the alcohols? Because they can be possesses generally ionic bondings. But suppose we have taken as concerned to here LiCl, in case of LiCl there will be covalent nature will be higher as compared to these metal chlorides, hence this will be soluble in alcohols, but they will be insolubles. Now again FeCl3 is soluble in the ether, but AlCl3 is not. Now if suppose we have taken as the ether, now again this will depend on the, we can say here that covalent characters. Now suppose we have taken here that is some series as concerned to, this is the halide series FCl Bri. Suppose we have taken 7th A group in the periodic tables. What happens in the 7th A group? On the top there is presence of chlorine. Chlorine is present. Suppose in case of the periodic tables what happens? If suppose we have taken as a 7th A. 7th A is nothing but halogen series. Here chlorine, fluorine, bromine, iodine, they will be present. Now generally what happens here, atomic numbers are increases. Now when we have taken atomic numbers are increases, automatic what happens here, the size can be increases, and once the size can be increases from the top, that time generally what happens here, the covalent characters will be increases. Covalent characters in case of here this will be increases as concerned to halides. Means here suppose we have taken chlorine, this possesses very small, you can say, covalent characters. Again this will be possesses higher. HI possesses covalent characters highly in case of the halide series. Now in this way again suppose we have taken a 6th group elements. These are the 7th A, again 6th A can be taken. In case of 6th A what happens? Oxygen, sulfur, selenium, tellurium, these are the elements. Now here totally, that is you can say oxide series, oxygen family elements, they can be also increasing, that is the size from top to bottom. Means here that is covalent characters can be increases from oxygen to tellurium from top to bottom when it becomes covalent characters in case of periodic tables increases, and due to increase of the covalent characters some natures can be changes. Now these ideas can be taken in case of, you can say, Fajns rule. Now this is the Fajns rule we have seen in the Fajns rule, that is how the polarization can take place. Again free polarization rule can be given by the Fajn in 3 forms. One is taken for the cations. Cations when we have taken size, again you can say charge. Again second anions, size and charge. Third will be taken as concerned to non-noble gas elements and noble gas elements. This idea can be explained here. Today we will stop here. Next lecture we will continue. That is decomposition temperatures as concerned to, you can say, some compounds.